Hello, welcome everyone. In this video, we're going to go over CS50's Problem Set 2 and I'll be live coding the solutions. As usual, this video is only for educational purposes only. I encourage you to all do the problem sets before you attempt or even watch the videos. And also a disclaimer, I have already solved the problems before. I'm just redoing it again. For clarity's sake and sort of think about if there are any other ways to do it and so forth. So with that being said, let's get started. So in this particular problem set 2, there are three sub problems, as you might call it. One is readability, the other one is Caesar encryption and substitution encryption. So we'll go over each one of them correspondingly. So let's first open readability. So as usual, I have my CS50 IDE open, alive, and kicking, and let's go ahead and fire up this thing. So let me create make directory PSET2. Okay, so I'm going to go to PSET2, and here I'm going to make directory readability, Caesar, and substitution, right? So if I open this, I should have 3. Okay, cool. So now what we're gonna do is we are going to go and attempt first the readability part. So let's go ahead. Let me go back, clear it actually. Let me push D instead so I can pop back into my previous directory, and from there continue after I finish the problem set. Okay. So now what we can do is we can do touch readability, readability.c. Okay, so what we're gonna do is we're gonna open readability. Okay, so this is how we're gonna approach the problem. So the idea in readability is kind of simple. The idea is that you're given a piece of text and you want to do some analysis on that piece of text, and basically you want to write a program that says whether this particular piece of text roughly corresponds to, say, the text written by a 5th grader, a 6th grader, a 1st grader, or even, say, high school, like 10th or 9th, and so forth. So that is the basic idea of it. And that is measured by this formula here. And I encourage you to read up all this, everything that this prompt has to say. But I'm just going to go over a solution and sort of live code the solution on the spot. I had to read this before because I'd forgotten most of it. But anyways, yeah, let's get started. So the idea is we want our program that takes in a string, right? So that's a good starting point. So let's prompt the user for a string. So let me go ahead and include stdio.h, include CS50.h, int main, return 0, and here what we're going to do is we're going to get string. So we're going to do string text equals get string, and then we're going to paste this text. So this is how we get the text from the user. So after we get the text, the next question is, what should we do with the text, right? So for this part, next, after we get the text, we want to analyze it pretty much. That's exactly what we want to do, okay? So yeah, so here you have an option of writing that logic to analyze this piece of text inside the main function, or you can create a separate function. Either thing works, and I'm comfortable either way. For the sake of this program, I'm going to write a separate function, which basically outputs the score or the index given a piece of text. So let's do that. So in order to do that, I have to declare a function. So let me first start here. So I'm going to say int score or index. I'm going to call it index equals get index, and I'm going to pass in a piece of text. Okay. And according to the prompt here, if the text is where is it here? Yeah, so if the text here is below grade 1, so I'm going to do if index is less than 1, I'm going to print f before grade 1. I'm going to print that. Else if the index is greater than or equal to 16, I'm going to printf grade 16 plus. Okay, let's copy this. And I encourage you to copy the code from the prompt because you might make mistakes while typing, and the checker, when you submit, it will not be happy about that. Okay, so the last one is actually want to print the grade corresponding to it. So these are the three cases, and then index, okay? So the idea is that if it goes above 16, you print 16 plus. If it's below 1, you print grade 1, okay? So, okay, pretty straightforward. Let's go ahead and write this function which analyzes a piece of text. So this looks like it should return an int, right? And it should take in a piece of string, right? So let's do that. Int get index string s, right? Let's copy this, write it below main. Let's start coding this function up, okay? So now what we want to do here is, according to the programming prompt, we want to analyze the total number of words, total number of letters, and total number of sentences in the given piece of text. So let's declare that. Int letters equals 0, sentences equals 0, words is equal to 0. Then what we want to do is we want to go through the text and analyze how much words, how much letters, and how much sentences are in it. So how do we go through a piece of string here, right? We can do that using a loop. So let's use a for loop here. In I equals 0, I is less than s strlen of s, I plus plus. Now to use a strlen, you have to actually import, I believe, a string.h here. So let's import that. So what do we want to do here? So what we want to do here is basically analyze and go through the piece of text, right? Just a minute, I'm getting a phone call. Sorry about that, there was a phone call coming, so it's kind of weird. I'm gonna have a lot of interruptions. Yeah, because, you know, quarantine and a lot of interruptions here with other people, so yeah, okay, anyways, let's get, so let's get to it. Where was I? So, you want to go through a piece of text and you want to calculate the number of letters, sentences, and words. How do we do that? The prompt clearly says that while going through it, the number of letters is a total number of alphabetic characters. So if it's an alpha of, so we get the current character here. Let's do that here. So char ch equals is, s at I. If the character is a alphabet, then we increment letters, okay? Okay, so spaces constitute words, okay? So anytime it's separated by words, so as an example, if it's hello world, this is 2 words, right? So anytime there's a space, I want to increment the word count, okay? So let me go ahead and do that. If it's a space, words plus plus. And if the third case is for sentences, sentences is basically if the current character, the prompt specifies if the current character is a, it's exclamation mark, period, or something here. Okay, here, yeah. Okay, let's copy that. So if ch is equal to this, or ch is equal to that, or ch is equal to this, question mark, sorry. So in those cases, the given piece of text is, indicates a sentence ending, right? So we want to be on the lookout for that, okay? So sentence plus plus. Okay. And after this, we have the total number of alphabets, letters, words, and sentences. One thing that is not entirely correct is that, and this, I actually tested this a while back, and you can actually, this is supposed to be 2 words, right? So hello and world. So as soon as it sees space, it's going to take that as 1 word. So the output of this after this loop completes, the words count will be actually 1. We actually want it to be 2, right? So what do we want to do? We want to actually increment the words here outside the loop also after this finishes, right? Because this hello world, after this loop finishes, the word count will be 1 because there's only one space here. But in reality, it's actually 2 words, right? So if we just increment words here, it's fine. It'll pass all test cases. But if we really want it to be more pedantic, what we actually have to do is we have to set a flag here and basically say that after the loop ends, if it has seen any alphabets, then increment the word count, okay? That's a small modification you can make if you want to make your program really thorough. But in this case, the test cases aren't very corner cases at all. They're pretty straightforward, in fact. So that's why I'm going to just leave it at this, right? So after we get the total number of letters, sentences, and words, what do you want to do? We want to calculate the total number of, we want to calculate the index. So let's go ahead and do that, right? So what is the formula here? This is the formula, okay. So copy this, and then here the L will be, yeah, so here for L and S, that they're pretty much percentages. So L would be a percentage, meaning percentage of letters, a ratio of letters to words, ratio of sentences to words. So let's go ahead and do that first. Okay, so I'm going to do float, what is it, L, and here you want to do that ratio thing, right? So here's where it's very, very important, because a lot of people make mistakes here, because when you divide two integers, the result is always an integer, right? You want to be very careful about this. So the idea is that if you want to divide two integers and you want to capture the float values, either one of them has to be a float, or etc. Right? So or you have to cast them explicitly as a float, right? So let's be cautious while doing that here. So I'm going to do float L equals letters times, we want to get this a percentage, but if we say letters divided by words times 100%, then that's not quite right, because these are integers. Letters and words are integers here, and this will result in an integer, like it could be 0 and so forth. So we don't want to do that. We don't quite want to do that. Instead, we're going to do something. So instead of saying like this, I'm going to specify as a float letters times 100 divided by words. Okay, in this case, it's always guaranteed to be the valid expression. So S equals sentences times divided by sentences. Now we have L and S, and we just plug it into the formula, which is this guy right here. Okay, cool. So after we do that, the last step is that this is actually another floating point number, but we actually want to round it up to the next highest integer, right? To see whether it's like which grade corresponds to. So we'll call the round function, which I think is defined in math.h. So we might have to go ahead and import that. So let's go ahead and import math.h. Okay, cool. And yeah, and after that, it comes here. This calls the given function, and we pretty much make decisions based out of this. So let's go ahead and quickly test this. Make readability. Is alpha is space. Oh, C type. Yeah, okay. I have to include C type. Include C type.h. Okay. So let's go ahead and test it right now. Make readability. Okay. So let's, I think in the bottom here, they have some examples here. So let's go ahead and test it with this guy right here, maybe. Oh, what? Oh, sorry. Readability. Before grade. So, okay. So we clearly made a mistake. So let's actually see where the mistake is. Oh, sorry. This is supposed to be words, first of all. And I think the rest of the stuff looks good. Let's check. Make readability. Grade 8, is that right? Grade 8, what about this guy right here? Grade 8, is that correct? Okay. Let's go ahead and actually run the checker here. while this is doing that. Okay. So just to reiterate, the idea is that we just want to go through the piece of text and we want to compute the total number of letters, spaces, and sentences. And the prompt clearly specifies what the definition of a letter, definition of a word, definition of sentences mean. So we can just follow the programming prompt. And test cases aren't corner case enough, so we can sort of roughly approximate it. So as in like with this example here, hello world, we can get away by doing this, but in reality we would place more stringent tests or checks around this. And we calculate L and S, which is just a ratio as a percentage pretty much, letters to words, right? And you have to be careful here, both are floats. Okay, let me go ahead and submit it, so this is fine. Okay, and then yeah, and then we round that we just plug it into the formula and just round it up to the next highest integer or the grade level. That's pretty much what we're doing here. That's all we have to do, pretty much. It's pretty straightforward, I would imagine, but let's check here. Okay, so that's that. While this is getting ready, ideally we should be starting the next one. So let's go ahead and start that. And then once again, if you're not able to quite follow it, just reread the programming prompt and watch the walkthrough here, which is pretty useful stuff. Okay, so next up is cipher. So idea here is to encrypt a given piece of text using some arbitrary shift integer or amount here. So that's pretty much what you have to do. So you're given some plain text here and you have to encrypt it. Okay, so pretty straightforward. I mean, I wouldn't say straightforward, but you know, you get the idea. You have to follow the algorithm to encrypt it pretty much. Let's open this before and make sure we got 100% on the functionality. 11 out of 11. Okay, cool. So, okay, so that's that. So that we got full points on that. So let's move ahead and clear this. Pop D. Then Caesar. Okay, and then touch Caesar.c. Okay, so now we're at Caesar. Let's reuse some of the stuff we wrote here. The common imports. Copy that. Okay, so okay, I'm assuming you already have gone through and read this prompt, so I won't spend too much of time like reiterating what the prompt is about, what you have to do, etc. You can read the prompt and watch the walkthrough for that. This is mostly presenting the solution, how I approached it, etc. Okay, so the idea is that we want to take in a command line argument here, which represents the shift. Okay, so let's go ahead and do that here. So that will be int argc and then string array. Do we have the example here in the notes? I think we do. Let me go ahead and try to see here. Notes. Command line arguments. Okay, it's already there. This guy right here. Okay. So what we're gonna do is we are going to. Okay. So now what we want to do is we're going to delete all this. Now what we want to do is we want to validate the command line argument. And we want to take in first actually. So we want to take in the command line argument, okay? And we also want to validate it, okay? So the idea of validation is basically looking at the total number of command line arguments. So we're going to say if argc is not equal to 2, yeah, so what happens is when we send through command line arguments, argv at 0 is going to be the name of the program, in which case is Caesar, and then arg1 is going to be the key, which in this case is an integer. If it's not equal to 2, then it's an error, so we have to return 1 according to programming prompt, and we print this guy right here. Okay, so let's go ahead and do that. Printf blah. Okay, so yeah, that's it. I mean, that's the first part of the validation. So let's go ahead and quickly test that out. So make Caesar. Okay, if you just pass in that, it should give an error. If you just pass in more arguments like this, it should give an error. But if you pass in exactly 1, okay, so it works. Okay, cool. Let me close this guy out. Okay. So the next step is you actually want to really validate this and make sure this is actually a valid integer, right? It shouldn't contain alphabets, okay? So what we're going to do is we're going to validate the key, okay? And the way we're going to validate the key is remember that this is passed as a string, right? So we just have to go through the string and make sure every single character in that is a digit, right? So I'm going to go ahead and do that here. So I'm going to write a function which basically says is valid string, valid key, I guess, right? And it's going to take in a string. And in this case, what we're going to do, all you have to do is say if argument count is not equal to 2, or if it's not a valid key, right? If it's not a valid key, the not operator here, of argv at 1, then we're going to throw an error, right? We're going to print this and return 1, okay? So then what we're going to do is we're going to go here and write the function for is valid key. So let's go ahead and do that right here. So is valid key, how do we determine if it's a valid key, right? All we have to do is it's pretty straightforward. So all we have to do is just go through the string, right? And we know how to do that using using a regular for loop and string length, right? And then if we have to use the function is digit, right? So think about this. A valid key is something that has only digits, right? Like this, right? If it has like something like an alphabet here, then it's not a valid. So we just go through one by one. So the string here, in the first iteration, the value is 1. On the second iteration, the value is 3. The third iteration, the value is x, right? So at any point of time, if we do see that it's not a valid digit, we just return false because it's not a valid key, right? So we can return false right then and there. Else, if it goes through and completes this entire loop and goes through all the characters, then by logic, we would have determined that it's a digit, right? So we would return true here. So that's all we have to do here, right? So yeah, that's pretty much it. So that's how we determine if it's valid key. Let's go ahead and test it, right? So the idea is that all we have to do is go through the string and test whether each one of them is a digit. At any point of time, if we do find that it's not a digit, if it's an alphabet or some other space or something like that, then we just return false, saying that's not a valid key, right? So let's go ahead and test that out. So let's say I make Caesar and I pass in 13. It's seg fault. Okay. What is seg fault? Let's check. Is valid key stir length is digit. Argv at 1. Yes, kind of strange why it's seg faulted. Let me check. Argv at 1. Oh, yeah. So sorry, this is a stupid typo here, but and it's a common mistake to make, because for is digit, it actually takes in a character, not the string, right? So this should be here. Actually, let me capture that in a variable. Ch equals s at I. The current character to be examined is ch, and this should be ch. Okay. So let me go ahead and do that. So the reason why it calls that is that for is digit, we are passing a string, not a character. So let me go ahead and do this now. Okay, so this works, but if I'm doing this, okay. So now this clearly works, as you can see. So now let's go ahead and do this. And so now here, it should be valid now. Okay, so now let's go ahead and write the function, or we can put it in main to encrypt it, okay? So how are we going to go about encrypting using Caesar algorithm, right? We just have to use this formula here, but even before we do that, let's go ahead and capture that in a variable. So what we're going to do is we're going to say string s equals get string, this guy right here, okay? And ultimately we want to print the ciphertext, right? %s, and we want to somehow print the ciphertext, okay? How are we going to do that? Okay, we can put the logic here, or we can put the logic inside another function. Let's actually put the logic inside another function, okay? How are we going to do that, okay? There are two ways of having a function return a string, sort of, to speak. One is through dynamic allocation, to allocate using malloc on the heap, and then return a pointer to it. The other way is just pass a static buffer to the function, and the function is going to modify it. Okay, so let's do the static string way. Passing a string to a function is a bit more complicated. It's better to if you do everything inside main, but let's just have some practice using functions. Okay, so what I'm going to do here is allocate enough buffer space here. So I'm going to do char ciphertext, and then let me go ahead and do int n equals strlen of n. Okay, so here I'm going to allocate n plus 1. The reason being, it's the characters of the plain text encrypted, but it's also going to have the null terminated character, the \0, which represents the end of string in a C, right? In C. So I'm going to do that, and what I'm going to do here is I am going to pass that into encrypt function, which basically takes in. I'll write this function out. So it takes in a ciphertext. It takes in a plain text ciphertext. It also takes in the shift amount, right? And what else does it need to take in? We'll come back to that, okay? Yeah. Oh yeah. We should at this point we should also get we should also parse the shift amount, key, right? I think instead of shift I'll call it k, right? Because that's what it says. Okay. K equals a to I. A to I don't remember where it's defined. In standard lib maybe. Let me check. Okay. A to I of arg v at 1, because it should be valid now, right? So this is the shift amount. So it's going to pass k here. Okay. So we have all the parameters that we require to start encrypting it, right? Well, the only thing that's left is we have to write this function out. So let's go ahead and do that. But before that, let's declare this. So this should be a void type because we're passing a string, right? So we're passing a plain text string. We're passing a ciphertext string. We're passing an int shift k amount, and it actually changes the ciphertext, right? So we're passing this as a buffer, so it changes that. Okay. So let's go ahead and write this actually. So now let's take this guy right here and start writing this out, okay? So here what we're gonna do is, actually even before we write this out, let's make sure it compiles as we go along. Okay, strlen of n, strlen of, oh, sorry, this should be strlen of s. That's okay, that's straightforward. Encrypt plain text, ciphertext, undeclared identifier plain text. Oh, I think I called it something else. Sorry about that. Let me just pass in s, right? Okay. Okay, cool. So now it compiles. So now what we're going to do here is we are going to just go through the individual characters in the plain text and encrypt it, right? So how do we go through individual characters? We just use a for loop as usual, right? So strlen of plain text I++. And inside the loop, we can get the current character, right? Using plain text at I, okay? So now we have to encrypt it. So how are we going to encrypt it? Okay, according to the program prompt, it just says that we have to use this formula here. So let me go ahead and copy that. This is a formula here. Okay, so C of I equals P of I plus K modulo 26. So here P of I represents the current char as an int, meaning A will be 0, B will be 1, and so on. Right? So how do we do that, right? So even before we get to that part, these are only applies for alphabets. So let's go ahead and also put is alpha around CH, else it's that, okay? So only if it's an alphabet, then we encrypt it, right? If it's not an alphabet, we just leave it as it is, right? So that's the logic that we have to follow here. So let me go ahead and put that here, okay? So what we're gonna do is we all have a ciphertext already. So if it's an alpha, we encrypt it. Else ciphertext at I is equal to ch, right? We're just going to leave this alone and just copy over the current character in the buffer to the buffer, sorry. Yeah, so let's go ahead and encrypt it. So how do we encrypt it, right? First we want to get PI, which is okay, so even before that, there's lowercase and uppercase here. So for lowercase, what we have to do is we have to worry about the ASCII range for lowercase, and for uppercase we have to worry about the ASCII range for uppercase. So instead of having separate ifs for both of them, what you could do is you could all convert it into lowercase, and then depending on if the original character is uppercase or lowercase, capitalize the ending result, right? So we run this algorithm, and then so say as an example, in the original piece of text, it's an uppercase, the current letter, right? We run our algorithm, and our algorithm always spits out a lowercase letter, and once the algorithm is run, if that final result, you can just capitalize lowercase or uppercase depending on if the original text was uppercase or lowercase, you know? So basically apply this formula in one case, like where there's only lowercase, where there's only uppercase, and then you can just capitalize it later on, okay? So let's go ahead and actually do that. So I'm going to go ahead and do that. So what I'm going to do right here is I'm going to actually capture PI and K. So I already have the K value here. The only thing I have to do is PI. How do we get PI? So int PI is equal to the current character minus lowercase a, okay? So what I'm going to do here actually is say, that's why I said actually I'm going to say temp equals ch to lower of ch, okay? I'm going to do everything in lowercase. In the very end, I'm just going to capitalize or lowercase, depending on if the original letter was uppercase or lowercase. So ch temp equals to lower, and I'm going to do temp minus a, right? And then what I'm going to do, so this is going to be PI. We already had the K value, and we already have 26. So the end result, so char CI is equal to just this formula right here, right? We just do this formula pretty much. Straightforward, okay? One thing, there's one small nuance here, which is that the CI being returned is actually an integer. So say you do this formula and you follow the formula, and this actually returns you something like 15, right? We have to look up inside the original ASCII what value that 15 is, or say this returns a 0, right? It should correspond to letter A, right? So the very last step here is to say, is to actually add up the A here, right? So that's just the idea of it, because this is an integer index. Basically, this part here is an integer index, okay? We want to map to the original character, and we can do that using plus A, right? So after we do that, then we have our encrypted letter, so we can just say ciphertext.I is equal to CI, right? And we should be done, right? One small thing, we have done everything in a lowercase, so we just want to check whether the original letter was uppercase or lowercase. So as an example, if this was original uppercase, right, something like that, capital A, we convert it to lowercase a, and we spit out the encrypted letter, but we need to capitalize this, right? So even the encrypted letter needs to be capitalized. So we have to retain some sort of symmetry here. So that's pretty straightforward. What we can do is we can just say is upper of the original character if it is, or actually let me do it the other way around. If the original character is lowercase, then I just have CI, okay? Else, and I'm using ternary operators here, is lowercase, else I just need to convert it to upper, right? The converted thing. So it's pretty straightforward. You can have two separate ifs if you wanted to, one for lowercase, one for uppercase, but I find it easier to just make all the changes in one case, whether it's uppercase or lowercase, then just change the final result or output, okay? So as a result, in the very end, if A gets encrypted to say B, it always going to get, here at this step is going to get encrypted to say B with K equal to 1, right? But I want to just capitalize it, so if the original one was capitalized, right? So that's what this part here does, okay? So that's it. Yeah, and that's just I'm pretty much done at this point. After this exits, we have our ciphertext, right? Almost, okay? Not quite. The reason being that we passed in a ciphertext buffer, right? And remember that in C, all strings are terminated by this null character, right? So we have to do ciphertext, we have to terminate our thing by saying ciphertext at I equals null character, and we're done, okay? I is, however, when we do that, I is not in scope. So we go ahead and declare I here, okay? And we do that. Okay, so and that should probably solve it, okay? So now let's go ahead and actually test it out. Okay, cool. One value, say A, we get B. Perfect, okay. So 1, A, B, C, B, C, D. Okay, so it seems to be working. Let's test with this example here. Caesar 13, right? Hello world, okay? Actually, let's test with this one because it has capital and lowercase. Okay, so seems to work. So let me actually do check, run checker, sorry, on this guy here. Okay, so just to repeat the logic here, nothing too crazy. I'm just following the programming prompt mostly. So the idea is that at a very high level, we just want to go through the string, take each character and encrypt it, right? And we can do that using the formula they have provided in the prompt, right? We just have to see how to plug in stuff to the formula. Okay, that's all we have to do, okay? So basically, if it's a digit, if it's an alphabet, we just encrypt it and retain whether it's uppercase or lowercase. We have in the final output. Let me go back here. Okay, this passes. Let me do this for the input, and if it's a digit or any other comma or any other punctuation mark, we just write it to the output buffer, and that's what we display. Okay, so that's pretty much it, the idea of it. So let me go ahead and check, waiting for results. Okay, while we wait on it, we can actually go ahead and get started on the next one. Pop the, oh, sorry, okay. Push the substitution. Okay, so now what we're going to do is going to touch substitution dot C. Okay, so let's go ahead and open that right now. Okay, so 11 out of 11. Okay, cool. So we got full points on that one. So now let's go ahead and do substitution. Okay. Okay. Actually, I don't want to start typing because we already have most of the stuff here for this thing. Okay, so let me quickly explain in substitution what the problem we're trying to solve is. Okay, and this is an assumption that you've already read through the prompt and watched the walkthrough. If not, please go ahead and do that right now. So the idea in substitution is very similar to the one in the Caesar program. The only difference being that in substitution, instead of a given integer key, you're actually given a bunch of letters. Okay, that is pretty much the mapping. Okay. To the alphabet. So as an example here, if I call substitution with this given substitution key, which consists of 26 letters, okay, the output will be an encrypted string in which each character here is mapped to the corresponding encrypted output. So as an example here, what the substitution key actually means is that the letter A corresponds to J, the letter B corresponds to T, the letter R corresponds to C, etc. So using that mapping, we have to encrypt our given string and display it as a, we have to take in a plain text string and display the encrypted string, okay? So that's pretty much what we do it. Same idea as the cipher, but a little bit involved with the substitution, the validations here. So let's go ahead and actually copy most of the template that we have here. And I believe we only have to change a few things here because, I mean, the idea is pretty much the same here, right? So if the argument count is not equal to 2, then it's invalid, okay? So same idea as that one. So let's just go ahead and copy that right here. Okay, let's go ahead and copy that. Sorry. Okay, so that's that. And then if it's not a valid key, the substitution keys, then we also have to print this one. So how do we determine if it's a valid key or not, right? It's a little bit more involved here, okay? So there are more conditions for this particular program, I believe, right? So let's go ahead and check that, okay? So what we have to do is there are 3 conditions actually that this programming says. One is it has to be 26 characters in length. Second thing, it has to have all alphabets, right? So let's take about all alphabets first, right? So it has to have all alphabets. So the idea is that if it's not an alphabet here, the only thing I have to change is here. If it's not an alphabet, we return false. So we go through each letter, each character in the string. At any point of time, if we see that it is not an alphabet, then we return false, saying it's not a valid key. So that's the first condition here. The second condition is that it has to be 26, okay? How do we determine that? Well, we can go through and count it, right? But this loop already does it, right? So let me go ahead and declare I here. I'll initialize I to 0 here. Here, and the loop completes, I can just do I is equal to 26. Okay, pretty straightforward, right? It should repeat 26 amount of times. If not, it's not full length. Okay. The next thing is I believe they have one more condition here, which is to say that there should not be any repetitions of a given letter in the substitution key. Okay, this is really tricky to code. There are several solutions, out of which one is sort of hacky, in which it just sums all the from A to Z, it sums all the variables up, and the ASCII value should be equal to exactly that sum. That's one approach. But however, I like to do it with a different approach, which is using arrays and buffers, basically. So the idea is, what I'll do is I'll declare a buffer here, which is int of size 26, right? And I'll go ahead and initialize all of them to -1, right? Anytime I inside the loop, I take each character and I take the corresponding index to it. So in this case, A would correspond to 0, B would correspond to 1, and Z would correspond to 25, right? And I can do that using simple as this. 2 lower of CH minus A, right? I index into that and I just set it to some arbitrary value, maybe 1, right? So here what I can do is, so it goes to each character and sets the buffer's position to 1, right? If there is a collision, right, then it means that when I try to index into my given buffer, it is not equal to -1. So -1 is sort of a default sentinel value, which has, when I initialize the buffer, at any point of time, if there is a collision, then that means that in the previous iterations, during some other iteration, there was a 1 written to the buffer, okay? In that way, I know that there's a collision because at this point in time, when I look inside the buffer, someone previous to me has already written a value of 1, right? And it's not -1, right? That's how I know. So if it's not equal to -1, then I return false, saying it's not a valid key because there is a collision, basically. There is a collision, right? Else, I keep on writing any value other than -1 because -1 is sort of a default value, okay? To it. And that's pretty much it, right? So let's go ahead and actually test this out real quick. Make substitution. Int I equals 0. Oh, okay, yeah, I think I have it initialized twice, maybe. Yep. Okay. Substitution. So if you pass in 12, it's invalid. If you pass in just substitution 34, something like this, it's invalid. But what if I pass in ABC, right? So it should be invalid because it's not 26, right? Okay, what if I pass in something with repeated characters? So this would be valid. Okay, so it's asking for input, so we're good there. But this, if I repeat, say X again, okay. So now our repetition algorithm also works, okay? So we tested this right now, okay? So now we're pretty much in good shape. We don't need A to I here because when we go back here, we don't need this thing, but we do need a mapping, okay, of the encrypted letter. So A should correspond to the encrypted letter, B should correspond to the keys encrypted thing. So let me go ahead and declare a buffer here, char mapping of size 26, and what I'm going to do is I'm going to iterate through here. Go 0, I is less than argv I plus plus, and I'm going to say mapping at I is equal to lower of argv at 1 at I. Okay, so this is going to create a mapping. So what this mapping is pretty much going to do is going to say 0th index, which is the A index, is going to be whatever the encrypted letter is, right? The key is, and 1 is going to be that. We're just making the mapping using this guy here. So it's going to say 0th index is going to have the letter V, which is going to correspond to letter A, right? C is going to have that, and so forth. Just a minute, there was a bell. I'll be right back. Okay, I'm back. So what we're going to do is we're going to take each character here and do a mapping, okay? So that's what we do here. So we take the substitution keys from the program, the user provides us, and we're going to do a mapping here. And this char mapping here maintains the array of the total mapping here, right? So going back here, V would correspond to index 0, C would correspond to index 1, H would correspond to index 2, P would correspond to index 3, and so forth, and each of them would represent the 26 the alphabets, the entire alphabets. Okay, so now after this point, what we can do is we can now we have a mapping. So now we can get string the plain text, and then we want to display ciphertext as an encrypted using the substitution algorithm, right? What we do is we call encrypt here. Now we have to pass in not these parameters, we have to pass in the plain text, the ciphertext. The mapping is already defined, so we don't need K here. There's no K here. The mapping is already defined as a global buffer, but we could pass in as an argument. But for the sake here, I'll pass in here. I'm just passing these two parameters, and this does that. Okay, so here what do we do? Okay, so we pretty much have the same logic as Caesar's algorithm, in which we have int I equals 0. Towards the very end, we add a null terminating character to signify the end of a string. And what we have to do here pretty much is go through the string and produce the encrypted letter, right? So same exact idea as the Caesar algorithm, but here, this is where things change, right? So when you're going through the each character, if it's not an alphabet, we copy it into the buffer. That part stays the same. The only difference is when we take each individual character. So what we can do here is we can just, what we have to do is just look it up inside the mapping, right? So we take the temp, we do 2 lower, we use this index here, temp minus A, and we do, instead of this running this formula here, all we have to do is do mapping at PFI. PFI, remember, recall in Caesar represents the index, right? So A will be 0, B will be 1, and so forth. And if you just look that up, okay? So once we look it up, we get the corresponding character here, the lowercase character. And what we can do is ciphertext at I is equal to, if the original one is lowercase, then it's going to be the encrypted one. So this is the encrypted stuff in both, right? So this is the encrypted stage, or whatever you want to call it, right? We encrypted using, in Caesar, we encrypted it using the formula. On the other hand, on this particular program, we're encrypting it using the mapping that the users provided, right? So you see how this template is very powerful. You can copy paste and reuse across multiple programs of substitution as well as Caesar's, right? So Caesar text at I is equal to is lower. If the original one is lowercase, then we just use C of I, because even in the mapping, we maintain all lowercase letters. On the other hand, if it's uppercase, then we need to convert it to uppercase, okay? And towards the very end, we just modify the buffer, so we just append a null character here. So I think that should pretty much do the trick. So let's actually go ahead and test it out here. So to test this, what we can do is provide this, provide this guy here, And let's provide this guy right here. Okay, so that's not working. So let's think about why that's the case. In mapping of I, we do mapping at to lower of every single one here. So that part is fine. Let's try to examine where the error is. So mapping at pi, let me think about it. So we have ciphertext here, and we pass in the buffer here. Let's see if it's even printing the encrypted text here. So printf encrypted text equals %c ci. Okay, so let's quickly check this. Clear substitution. Hello. Okay, so it's not even entering there. The reason being why strlen of plain text. Is it even entering here? Let's check. Plain text at I. Okay, so let me just print. Oh, did I forget to make it maybe? I don't know. Oh yeah, I forgot to make it actually. That was the problem. Okay. Okay. So let's unidentified CI. So let me take this out here. Make a substitution. Oh yeah. So strlen of arg at 1. Now make it, okay, clear it. Substitution of this guy right here. Paste that hello. Okay, so is that the right answer? Okay, let's take hello world. Okay, seems to be right. Let's run, okay, let's do something else. This, but if I do like this, okay, so it's retaining the uppercase and lowercase correspondingly, which is good. So let's go ahead now and sort of run it with a checker here, okay? So, and then while it's running, I'll reiterate what I did here. Okay, so to recall here, what we did here is all we have to do for this particular programming prompt is given a string, we have to encrypt it. Same idea as Caesar. But the idea is that we go through each character and basically take each character and encrypt it, right? So before we encrypt it, we first have to validate that it's a valid string, right? Valid key, right? Let me first submit this. Let's see. Okay, we have to first validate its valid key, and the program prompt really specifies what are the conditions required to make sure that's valid. So we go ahead and do that. After we do that, then we create a mapping, right? So which basically says the letter A corresponds to V, the letter B corresponds to say X, and so forth. And we can do that using indices. So we can just say we just maintain a mapping buffer, and that we just put the corresponding characters into the buffer, okay? And later on, when we after we create the mapping using what the user has given us, we just run our encryption algorithm, which basically consists of going through each letter in the given string and encrypting it, right? If the given letter is not an alphabet, we just leave it as it is and we write to the output buffer, else we have to encrypt it. Now the question is, how are we going to encrypt it? We can encrypt it using the substitution mapping that we created in our earlier buffer, right? So what we do here is we say, examine the current character and look up that inside the corresponding buffer, and just take that corresponding value of it and just write it to the output buffer, right? So as an example, if the current character is capital A, right, and in the mapping, it's actually corresponds to say letter H, right? Then after this, we can just put H, but we just have to see if the original character is uppercase or lowercase. In this case, it's uppercase, so we just write capital H to it, the output buffer, okay? And we do that for every single character, and we write that. And that's pretty much it. And after we do that, we just have our encrypted ciphertext, and we can just go ahead and print that out here on line 32. Okay, so let's go ahead and see if it passes everything. Okay, 15 out of 15. Okay, that passes all test cases. That's pretty much it. Hopefully that was helpful. One tip is that, I just mostly follow the programming prompt. And in most cases, you can just copy paste some of the stuff from the programming prompt, like formulas, the input and output prompts, etc. And you can just follow the algorithm as it's stated in the prompt. The only thing you have to do, it takes a little bit of practice, is how to translate in English, from English to computer programming language, by reading the prompt. And that's exactly where the walkthroughs come into play and are super helpful. So I personally advise you to read the prompts, as well as watch the walkthroughs and attempt on your own, and then come to these videos. But hopefully these videos kind of make some sense. So as sort of a last time sort of summary, we went over 3 prompts in this particular problem set. One was the readability program, which basically says, given a particular string, compute the readability score or the index, and that's formula is already given to us. So all we have to do is analyze it and compute how many sentences, how many words, and how many alphabets, so letters, words, and sentences are in that, and we just use a particular formula. Okay, we just plug it into the particular formula, and we just display it. Okay. In the second prompt, we had Caesar encryption. So second and third was encryption algorithms, where we basically take a given piece of text and encrypt it. Okay. So in Caesar's case, it was we're given a particular shift value, and we just move the given piece of text by that shift value, and we encrypt it that way. And we just have to go through each character that's provided by user and apply the algorithm. Okay. In the case of substitution key, we do the same exact thing, but there's no longer a notion of key or shift. There is just substitution, right? So we just go through each character and substitute it by whatever user provides us, and we maintain that mapping data structure inside our program. So hopefully that made some sense. See you guys in the next video, where we solve problem set 3, and we do some live coding there. Let me know if there are any questions in the comment below, feel free to like, share, and subscribe as well. So take care and stay safe. Thanks.